Hey Lancers, here we go, section 12-2, and this is a super special edition because this is my fourth try trying to get this video done. Okay, so chords and arcs, here we go. In section 12-1, remember we talked about tangents, and tangent simply means there is a line that did not cross the inside, just the outside, and it only hit 1 point. All right, so guess what today is, right? So today is about a line in a circle that is created by 2 points in that circle. Alrighty? So that's called a chord, right? So if a chord touches 2 points in a circle, and it is a line segment, not like a tangent, where a tangent can be a ray, it could be a line, but not a chord, right? Not a section. A chord is a line segment. And what that chord also produces is an arc, which is just a segment of the circle. So in this case, that's called PQ, arc PQ, and then this guy is called line segment or chord PQ. So I'm going to throw a lot of theorems and rules at you right now, so just try to follow along. I'm going to explain these pictures. For your notes, it might be best done just by drawing the pictures as well. But we got a lot of rules coming at you regarding these chords, okay? And arcs, I should say also. So the first one says, if you have a circle, right, or if we have two circles that are of the exact same diameter or circumference, we're going to look at matching angles. So if these angles are the same, then we know that these arcs are the same. So hopefully that's pretty much a no-brainer. And the reverse is true as well. That's called the converse. That's why it says the converse. So what does it look like? I guess if you wanted to write some notes, I would even just write it like this, right? We got x and y. So if you know that angle x is equal to angle y, right? Or we'll do that right. We'll use a congruent sign. Then we know that the arc AB is congruent to the arc CD. All right, so there's your first one. Next, moving on. Look at that, we got a couple theorems here. We're going to take that same theorem in regards to angles. So again, this is our central angle because it's chords or whatever. Angle is created off that center point called the center. And so, oh, this kind of looks like a face, how funny. So if, again, we know that angle y, or x, is congruent to angle y, then we know what? Dun, 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 dun. I'm sure you guys are thinking that. The arcs, oops, not the arcs, the chords are also the same, right? So the chords created by those lines are also the same. So I'm trying to write and talk at the same time and record. It's all working out fantastically. So here we go, right? So we know that those guys are the same, therefore the chords are equal to each other. And so one more thing is that if you know that they are equal to each other, it should only make sense, right? So let's just do this as an example here. Should only make sense if x is equal to y. There it is, angle, angle. Then we know that the chord AB is equal to the chord CD. And also the arc AB is equal to the arc CD. Now that being said, right, if you remember how this picture started, it didn't have those. So we'll just wipe all that out. And I can say if the chords are equal, then the arcs are equal. I can reverse those around, right? And throw that there. If the arcs are equal, then we know the chords are equal. So I tried to sum those up quickly as possible there. All right, and let me just jump out. Here's an easy problem. Basically it says, right, given BC, it's just an easy problem. This says if you know that these guys are equal, right, the chords are equal, what do you know about this circle? Well, what we know about these circles is obviously that BC and DF are the same, and we all also know that those the central angles are going to be the same. All right, one more problem coming at you here, or I should say theorem coming at you, that's 12-7. And that has to do with just how, okay, great. So we have our chord here, right? And we know the chords are the same distance away from the center, right? And how do we know that? Well, those little lines there, those are indicators, okay? So we have this red line here and that red line there, and they have the little dot, right? The little hashtags there saying that they are, or tag marks, whatever you want to call them, indicating that they are congruent in length. So if you know that they're equal distance away from the center, then you know the chords are equal. And then you should also say in your head, well, and if that's the case, then I also know that the arcs created by those chords are the same as well. Okay, so hopefully that makes sense. I had asked for any questions, but it's just a video. Here we go. A proof. Just kidding. That just looks terrible. So let's skip that guy. And let's do an example problem. All right. So real quick, and this is an easy one. This will be it for this section here. And that is saying, what is the length of RS and angle or in circle O, right? Okay, so what is the length of that guy right there? So let's take a look at some of our rules and what do we know? Well, first of all, we know that this guy is 12.5 and obviously that guy is 12.5 because of these little indicator marks here. And remember from what we just said right above in the theorem, if we know that these lines, these chords are equidistant from the center, all right, so that one's 9, that one's 9, then that is going to tell us that the chords are equal. So this chord is the same distance from the center as that chord. So look how easy this is. Therefore, this is also going to be 12.5 plus 12.5, and that's a terrible 5. So that is 25 units, whatever that is, all right? And yay, I have the answer here. I suppose we could do this, right? This one's easy too. This is lame. So this chord is 36. This chord is 36. So reasoning should have it. If you have congruent chords, then they'll be the exact same distance away from the center. So that x is equal to 16. Alrighty, that's it for this video. See you in the next one.